Okay, this video is about difference quotients, and this is a beginning lesson of calculus, if you will. In calculus, we'll be finding slope of tangent lines, and how you do that is with difference quotients. You'll learn more about that next year, but this will kind of give you an idea of where it's going. Okay, so remember from algebra, if you had a basic function, f of x equals x squared minus 1, and they said to evaluate it at f of 3, well, you would simply do 3 squared minus 1, which is 9 minus 1, or 8, right? If it was evaluated at 4, you would plug a 4 in for x and do 4 squared minus 1, 16 minus 1, which is 15. So far, so good. But what if it's a variable? You would plug in a instead of x, and you would just have a squared plus a squared minus 1. And that's all you could do because you don't know what a is. Then what if it's an expression, an a plus 1? Well, you got to put that whole thing in there. And then you would have to multiply this out. And remember, a plus 1 squared is two binomials multiplied to one another. So you have to do box or FOIL. So if I do first terms, I get a squared. Outer terms, I get 1a. Inner terms, a 1a. Last terms, a 1. So what I really have is a squared plus 2a plus 1. Come back to my original problem, and I have a squared plus 2a plus 1. That's all this first thing right here. And then I have this minus 1 attached. Well, the 1 minus 1 is going to cancel out, and what I have for a final answer is a squared plus 2a. Okay, so there's a little more to do. Even though I don't know what a is, I still have some more algebraic things I need to do to complete the problem. So what we have is called a difference quotient, and this is the pattern you follow each time. It's the limit as x approaches 0. So at some point in here, we're going to be substituting in 0 for h, but that's not until the very end of the problem. First of all, you substitute in x plus h for x. Then you substitute in x, and you're going to subtract the two functions. I'll show you what I mean. And then you divide it by the variable h. All right, don't get overwhelmed. Let's just take this in baby steps, okay? So first, I'm going to do f of x plus h. So I'm going to plug in x plus h for, and what I will get is 2 times x plus h plus 1 minus f of x, which is 2x plus 1. Okay, that's this part right here. Now over here, before I divide by h, I'm just going to distribute this 2 out. Okay, distribute it out, so 2x plus 2h plus 1. Now remember, this minus is like a minus 1, and then you have to distribute it across the terms. So you have minus 2x minus 1. All of that over h. Now, combine like terms. See what happens. 2x minus 2x, those will cancel each other out. 1 minus 1 is 0. What I have left is 2h. 2h divided by h. The h's cancel out, and what I have is a 2. That's my answer. Okay, there was no place to plug in 0, but my answer is just a 2. So the limit as h approaches 0 is 2. That's really what your answer is. Okay? Let's try another one. The limit as h approaches 0, f of x minus f of x plus h, minus f of x divided by h. So let's do this. X plus h squared minus, now the whole thing in its original form. Alright, now x plus h squared, remember, you got to box or FOIL this. So come to your margin or wherever and figure it out. X squared plus xh plus xh plus h squared gives me x squared plus 2xh plus h squared. Alright, so I can plug all this in right here. Now I bring in the minus 2. Remember, this is a minus 1, and I distribute. Minus x squared plus 2. All of that over h. So then I combine like terms. X squared minus x squared, that's 0. Negative 2 plus 2, that's 0. So what I have left, 2xh plus h squared over h. Well, I can factor an h out of both terms in an effort to simplify. I get 2x plus h over h, right? These h's will cancel, and then remember I'm taking the limit as h approaches 0. So I have, what I have left when I've simplified it is this. Now I substitute in 0 for h, which means it's just 2x. Okay? So your answer can look like this. It can still have an x involved, that's okay. But you've simplified it down. Alright, last example. Same pattern, f of x plus h minus f of x over h, alright, as h approaches 0. So here's my equation. It's a little bit longer, but we can deal with this, okay? So 3 minus 3 times x plus h minus x plus h squared minus, here's the whole original equation. Alright, now before I go any further, I want to figure out, okay, x plus h squared. Well, that's x plus h times x plus h, right? Which is x squared plus 2xh plus h squared. So now I'm going to substitute some things in and distribute when I can. I'm going to distribute by negative 3. And I'm going to put in what I got when I squared this mess. Distribute here, distribute the negative 1. Now I still need to get rid of this set of parentheses in here by distributing the negative 1 across each term. Minus x squared minus 2xh minus h squared minus 3 plus 3x plus x squared. Alright, so you have a long mess of things. Now let's just eliminate what we can. Alright, I have 3 minus 3. That cancels out. I don't have another 3x term. I don't have another 3h term. X squared, negative x squared plus x squared, that's 0. So, oh wait, I have a negative 3x plus a 3x, don't I? So I can cancel those out. Now, let's just see what we have left. We have negative 3h minus 2xh minus h squared. Alright, well, hopefully you recognize that you can take an h out of each term, right? Because ultimately, remember, you're dividing by h, and if we can cancel that h out, life becomes simpler. So let's do that. Let's take an h out of the top terms. That leaves me with negative 3 minus 2x minus h. All of that over h. These cancel. So now I need to finish with the limit as h approaches 0 of negative 3 minus 2x minus h. If I plug in a 0 for h, I'm left with this guy right here. So my answer is negative 3 minus 2x. Alright, that would be my final answer. Alright, a lot of work, but you're getting down to the nitty-gritty here. You're finding out what happens if there's a change of your x value. That's exactly what this is doing. It's finding a slope of a line, which sounds strange, but that's what you're doing when you're doing a difference quotient. Okay, I want you to try this one for class. Okay, take it in steps, show all your work so you don't lose a step, and see you in class.